confidence. In fact, everybody's serving back here. So should we wait for 2 more minutes, or everybody's here? I don't want to make people stay. Should we go? What do you guys think? I feel like the part from I live in the Netherlands now, and when you say like a time, you have to be exactly that time. You can't change 1 minute. It has to be exactly. So I feel like I don't want to start early. Is it 2 minutes? It's okay? Okay. So this is we're on to today's slides. So it's the packet for today. We're just starting session 6. We're gonna skip the session 5. You guys can look through the slides. It was mostly a review from yesterday. I don't know what page it is. Is it maybe like the 4th or 5th page of the packet, something like that? And this is 6A. And did everybody find the slide in the packet? Is it like which page is it? Maybe like the 5th or 6th page? So it's the 4th page. 4th page from today's notes. So there we go. It's got a crazy graph with all sorts of. I'll hold it up here. This is the one. The graph here. That's where we're at. Okay. So we are starting to build this kind of story, right? Think of what we're doing as like a story, and we sort of now know some of the characters in the story, right? A flux is a character in our story, right? And we kind of get to know a flux a little bit. So a domain is a character in our story, right? We kind of know what a domain is, spatially, temporally, right? That's the easy part of the story. It's just kind of getting to know what those terms mean. Now the story takes like a little twist, right? Like every good story should take. And it all of a sudden becomes clear how difficult doing these water accounting activities actually are. Because now we're going to talk about actually measuring things, right? And fundamentally, I love this topic because I'm fundamentally a measurement person. I love to observe things. So I love those Kahoot quizzes because I'm observing, and I get numbers about it. And I see quantitative evidence of if I'm doing a good job teaching you or not, right? So that's why we do the Kahoot part. It's for you to have fun, but it's also for me to measure you, right? See, measurement's important for almost everything. And so I love this quote. Does anybody know who Lord Kelvin is here? Lord Kelvin? I'm going to go off there. Don't look at your pages. He's a Scottish mathematician and physicist, of course, yeah. Lord Kelvin, does anybody recognize this here? Kelvin? Yeah, well, he has a unit named after him. He's an important guy, right? He's a very, very wise man. He said, this is a paraphrase. He didn't say this exactly, but you can't manage a resource you don't measure. Dr. Puspo kind of shared this yesterday, right? We have to measure the things that we want to manage, okay? So, for example, this is kind of like, wow, what is this graph showing? Okay, this is in California. I'm from California, right? And in the northern part of California where we grow most of our rice, there's a river called the Feather River. And this is a graph showing the last 100 years. And what it shows is the amount of runoff that occurred between April and July, okay? And it's for the last 100 years. Now, do you have a graph like this for any rivers in Myanmar? Are there graphs of 100 years of data every year for Myanmar? I'm not saying it's a bad thing. I mean, I wish we had it, but the reality is we don't, right? Right? Now, I'm very thankful in California we do, and you know why? What do you see in this graph? What do you see? What's happening? So we have this trend line here, right? We have this linear regression. Then we have this dotted line is this 3-year running average, right? So yeah, so there's ups and downs, yeah? There's definitely ups and downs. That's called climate variability, right? In California, we have very wet years, we have very dry years, right? Here's a wet year, here's a dry year, right? In fact, this was one of the worst ones here, okay? But if you look at the overall trend, what's happening? It's decreasing, right? Why is this happening? This is runoff from April to July. You have to know something about California. In California, it snows and rains from November to March, pretty much. Then it starts to get hot, and our hottest period is from May through October. That's when we grow our food, so it's a little bit different in here, right? You have a winter from October to March, and then kind of a summer from April through September, okay? So this is the period when the snow would melt and come off, right? But what's happening is that year after year after year, the snow is coming off earlier. Maybe it comes off in March, February. And so it's declining year after year after year after year. And if you continue this out, right, it's not good. Because we use this water to grow our rice. If we didn't measure this, we wouldn't know this, right? You see the power of these data? Because we've measured it, wow, we can actually see, look, it's decreased by maybe 20%. It's gone from 48% to 38% over 100 years. If we go another 10% down, these are the consequences. We need to start planning for this, right? If we can't plan, we can't manage if we don't measure, right? So in 100 years from now, can we make a promise to each other? Right now, in 100 years from now, I think I won't be alive anymore. I don't know if any of us will. Maybe let's say 50 years from now. 50 years from now, maybe some of us will be alive. Still, I hope. In 50 years, when we come together for water accounting reunion, yeah? Can I put a graph like this of the Ewadi? And we can look at the last 50 years of data. And there's no gaps. There's no gaps in the data, right? We have every year we have good data because we know how important it is. Can we do that? I don't know if any of you control this. I don't think you do. But can we do our best to make sure we have data in 50 years? That's kind of. Are any of you decision makers that affect this? Like, do any of you decide what to measure, where to measure, maybe how much money you put towards measurement? Do any of you have that as like a job? Is that? Am I clear? What I'm asking?
No. Because the idea to time now time is we got so much challenge the town.
Yeah.
Yeah, I'll be there.
Yeah.
I got seen the whole. Yeah, we were doing it. Really well, yeah, we were doing it, but the same object.
Because it could be measuring the yield from crops, right? That's the Ministry of Agriculture, the yield data. Please measure that. We need that. We can't manage crops if we don't measure it, right? It could be the flow in rivers. I don't know who that would be. It could be the flow in the canals. It could be the deliveries to your fields. It could be groundwater levels, the hydrogeologists, right? Groundwater levels, groundwater quality. Measure those things, please, all of them. So that, yeah.
Time is related. I say we can have to be. I tell you, I'm going to take up property. Keep it all over property. And all the guys is related. They say I need to keep it up in that. Long you don't go efficiency blocking of that. What is that? I got get them out of the see anything from another sheet. And that is another guy. All of that, the lab out to the kind of way down. Only something that China has some China, but then China is actually Japan này cũng bị thảm khổ. Thứ ba đó là bảo là đâu có là gì có gì để cái code advice.
Exactly. But in 10 years, I think these people will be.
Yes.
Yeah. And
Yeah.
then in 30 years, you'll be the president. Some of you. Who's when you become the president, you please make good policy about measurement. Okay? That's what I want you to promise. Okay? Yeah. Who has any ambitions to be in? We can talk. It's okay.
Yeah.
Okay. So this is an outline of what we're going to talk through, right? Measuring these fluxes and changes in storage. And then we're going to spend a lot of time on this partitioning. What I mean by partitioning is like if you measure one thing, sometimes in terms of water accounting, like that one thing you're measuring, you have to split into maybe 2 different categories or 3 different categories. We'll talk about examples. I think we're going to go through that mostly in Myanmar. Dr. Tim's going to do that. Uncertainty, this is really important. We're going to talk about that, and then maybe we'll have time for an exercise. I hope so. Okay. Remember this picture? We're going to come back to this picture over and over again. Remember, it's a pretty picture, right? It's really simple. It's nice, but we need to actually quantify each of these fluxes, right? So we've gone through this several times, right? We're going to specify our domain in space and time, and then we're going to conceptually, right, identify these fluxes and changes in storage. And the questions we ask ourselves when we do this, we say, what are the inflows? What are the outflows? And what are the changes in storage? Okay, so we've done this. This is repetition. So we get our magnifying glass out and we choose our domain, right? Choose the field and we do this. Okay? Or, then the questions come in. Okay, so what are these numbers? How do we actually measure this? That's what we're going to talk about here. Okay, maybe we're, okay. I want to spend a little bit of time talking about this because, see this picture here, right? This picture here and this picture here, they're the same or they're different? I mean, I don't know. To me, they're not so much the same to me. To me, they seem different. Do they or no? I mean, because look, if we look at this one has like surface water outflows, deep percolation, ET, and pumping. It has all these very specific things that we know, right? But this one has all these terms I don't know what these mean. Committed, uncommitted, storage, outflow, depleted, available. Do you see any of those here? I mean, there's like storage is the same, right? But there's a lot of different words, right? So the point I want to make is physically this is the water balance, right? But see this ET here? Can we make a little imagination here? Can we say that this side is weeds? Remember weeds? Is weeds beneficial ET or not beneficial? Yeah. Okay. Now can we say that this side is rice? This is beneficial or not beneficial? Okay. So can we imagine we have 2 arrows now for ET, right? When we measure them, we're going to probably measure ET for the whole field, right? We make one measurement of ET. But okay, so we make one measurement to try to fill in the question marks. But we know that there's weeds and there's rice. Yeah. So when we take that one number, okay, can we go to here? Where does that number belong now? Does it belong here in beneficial or down here in non-beneficial?
We know what ED will damage.
Depletion.
It is a depletion, absolutely. Okay, we can agree on that. So we know it's not an outflow. It's absolutely a depletion, right? Okay, good. So ET belongs here. But is it beneficial or non-beneficial? You say it's both, right? Okay, so this is what I mean then. We need to partition that. We need to split it into its respective, it was one flux, right? So in terms of the water balance, it's one flux, right? It's ET. It's one way that water is going from in my domain to outside of my domain. Yeah? But in water accounting, we're going to split it. And we're going to put maybe some of it in beneficial, the part from rice, and then some of it in non-beneficial, the part from weeds. And here's why this is important, because if you just do a water balance, right, you say, okay, my ET is 100. Then you think, okay, my ET is 100. If you don't know that half of that, 50, is non-beneficial, you might make a bad decision, right? See, lumping it together, you kind of lose the important information for making decisions. So when we split it now, right, now we can say, okay, that 100, 50 of it's beneficial and 50 of it's non-beneficial. So when I look at the water balance, I might not see this, but when I see this diagram, I say, what do I need to do to my field to make my field more productive? What should I do? I think this is a really practical thing. Here's my field. I have 50% of my field is weeds and 50% is rice. What should I do? Pull the weeds and plant more rice, right? Right? I want to get rid of the weeds and I want to only grow rice, right? Right? So maybe I need to use some herbicides, right? So that I kill my weeds and I just let the rice grow, right? Or maybe I need to control the level of my water better, you know, so that the rice is an aquatic plant, right? And a lot of the weeds are not. So if you put some water on, it might kill the weeds and let the rice grow, get a better stand, better yield, right? I'm looking at my agriculture friends here. That's why I'm talking to them.
Yeah. နည်းပြန်ရှင်းပြရအောင်နော်အဲ့တော့တကယ်လို့အခုဟုတ်ပြီဒီမှာဒီ bleaching နဲ့အကြောင်းလဲပြည်ပြီးသားဒီကနေပြီးတော့ထပ်မယ်ဒီ EPR ဒီ bleaching ဆိုတာအားလုံးပြည်ပြီးသားနော်လက်ခံပြီးသားအဲ့ဒီမှာမှာ beneficial နဲ့ non beneficial ကိုပြန်တိုင်းအတိုင်းဥစ္စာမဟုတ်ပြီ beneficial လည်းပါမယ်နဲ့ပြည်ပြီးသား non beneficial လည်းပါအဲ့တော့တကယ်နဲ့သဘာဝကြီးနဲ့ပါဒီပေါင်းတင်ကလည်းရှိပါတယ်နော် non beneficial ကို short ပြီးတော့အကျိုးရှိတဲ့ beneficial ကိုတိုးစေတယ်လို့လုပ်ရည်ကြီးရှိတယ်ဟောရှိတဲ့ဥစ္စာပါကဲပေါင်းတင်တခြားနည်းနဲ့လုပ်ပြီးတော့မှနောက်တစ်ခုမှတစ်ခုပေးတဲ့ဥစ္စာပါဒါဒီလိုပေးတယ်သဘာဝဆိုတာဒီနဲ့တွင်းစိုက်ရဒီနဲ့လည်းရဒီပြည့်တယ်အဲ့လိုဒီကိုသွင်းထားလိုက်သွင်းလိုက်ရင်တော့ပေါင်းမကြသွားတယ်ဒီနဲ့တွေမရဘူးဒီပါလို့လည်းကြောက်လို့ဒီပြုတ်သွားလို့ပေါင်းပြီးပြီးသွားတယ်အဲ့ဒါကြရင်ဒီနည်းနဲ့လုပ်ကြရတာဆိုဥပမာပေးတယ်ဥပမာပေးတဲ့ဖြစ်ကြတော့ပါပဲစဉ်းစားအောင်တော့ beneficial ကို short ကိုတက်နိုင်တယ်ညာ beneficial ကိုတက်နိုင်တယ်ညာဟုတ်တော့ ET ကိုကျွန်တော်တားလို့ရတယ်ငွေမပြအောင်တားလို့ရတယ်ဘယ်လိုမှဖြစ်နေရှိမဲ့ဒီလိုကတော့အကျိုးရှိတဲ့ဟာကိုများရှိအောင်လုပ်ပြီးကောင်းတယ်ဟုတ်ရတယ်
So this translation from a water balance to the water accounting is really important, and it helps us make decisions. It helps people interpret the water balance data in kind of more intuitive way. Okay, so that's where we're going. That's like a preview. Okay. But the problem with all this, right, is that in many parts of the world, including Myanmar and Nepal, Afghanistan, Pakistan, the U.S., anywhere pretty much, water is difficult to manage, partly because we don't have these data, right? Because we don't have the numbers to fill in the question marks, right? That's what you all just promised to work on, right? For Myanmar, for your country, okay? What I want to do is we're going to be working for the next 3 days on the Palay Sub-Basin, which is within the Chinwin watershed. It's in the lower Chinwin, okay? And what I'm going to do is just show like 1 or 2 slides, and then our colleague, I don't remember your name, sorry. Yes. Our colleague will share tomorrow some more details, right? But I'm just going to introduce it. The Chinwin is about 114,000 square kilometers out of the, or these are square miles here, 44,000. And that's out of the whole Ayeyarwady is about 414. So it's about 1/4 of the area is the Chinwin. And then inside the Chinwin, we have this smaller area, the Palay Sub-Basin, which includes this 99 pond artesian zone. There's some flowing wells, so that's kind of the idea of this artesian. And I think our colleague will share about that. And then the area, at least the way that I'm looking at it, is it's about 2% of the entire kind of lower, the entire cheek. Okay. So let me show a little picture here. Does this look familiar? Area here. I'm gonna kind of explain this. So I think Mandalay is like here. Yeah, that's maybe we're in Nepido. So we're like maybe there. I'm right here, and you're right here. Yeah. Okay, so Yangon is in the ground, and so we have the Ayawadi coming, and then the Chinchon coming. Right? Have you guys been here to the confluence where they come together? Has anybody been there? Nobody's been there? Oh, come on.
အခုဘယ်နော်အခုချင်းနေတဲ့ရောင်လေးနဲ့ပြည့်စုံနေတယ်အခုထန်တာထင်တာတော့အခုရထင်တာထက်တာဟုတ်တယ်ဒါပေမဲ့ကျတော့လည်းခက်တာပြီးသက်သွားပြီးတော့အကြောင်းရှိတာအေးရှိကြတယ်ဟုတ်ကဲ့ဘယ်တော့I
think we should go. We should. Yeah. Okay. All right. Okay. These are some big rivers. I want to go see them. I'd like to go stand on the river. Maybe try to swim across. You want to swim?
No, walk.
Okay, we can walk. That's what we're saying. Okay. And then so right before this confluence, right? There's these two rivers here. The South Yama, Tong, I guess. Yeah. I think that means like a river that flows. Sometimes it doesn't flow so much. Is that right? It's like a creek. Yeah. Stream something. Yeah, so it's like we call it a ephemeral. You know that word, ephemeral? Ephemeral and chong is same thing. Yeah. Okay. So so this is the north one and this is the south one. And actually I made these lines here. Does anybody know what these black lines represent? What do those black lines mean? Okay. Yeah. So like I'm gonna imagine I'm a raindrop. My finger's a raindrop, right? So I'm a raindrop and I land right here. Where do I go? If I land on the ground, where do I go? This way? No. See this one right here? Maybe that's a river. So I maybe go to the river and I go like that, right? What about if I'm right here? Where do I go? I think there's something here maybe. I don't know. I go maybe this way, maybe this way. Okay. What if I land right here? Where do I go? Yeah, I go to here, and then I go to here, and then okay, okay. So this black thing here, we all know this is called a watershed, right? This is my watershed boundary. What it means is it's like if I'm inside the watershed, I flow to this point. If I'm outside of the watershed, I flow somewhere else, right? So all the rain that lands inside this line is going to flow to this one point, right? Or some of it might be evaporated. Or some of it might go to a change in storage, right? And then what does this line represent then? There's a specific word we call this here. Yeah, if we think of it conceptually, it's like a ridge, right? It's called a watershed divide, right? And so if the water lands right in the middle, maybe half goes one way, half goes the other, right? But the drops are too small for that. So if it's here, it's going to go into the North Yama, and if it's here, it's going to go into the South Yama, okay? Now, I actually made these pictures of the rivers and the watersheds myself in about maybe 2 hours using free data from the internet and a free software called QGIS, right? You guys can all do this. This is all free. This image is free. What do I use to make these, by the way? What do we call it? We use a certain type of data that satellites measure with what's called aperture, synthetic aperture radar. It's called a digital elevation model, right? Digital elevation model. Yeah. And the DEM for Detroit, yeah, got digital elevation model. So I use the digital elevation model. Where can you get it, maybe our GIS folks, where can you get digital elevation models from?
Website, Google Engine, also you can download.
Yeah, so there's Google Earth Engine. There's the Hydro Sheds. You guys use Hydro Sheds? It's a really wonderful website. So all this data is free. Next training, do you guys want to learn how to do this if you don't know how to? Who knows how to do this already? Maybe you guys know. You guys know. Would it be helpful for other people to know how to do this? How to make a watershed? How to make the stream network? Yeah? You ask?
အဲ့ဒီဒီလိုပုံလေးတွေဆွဲတက်ခြင်းကိုလေ့ကျင့်ကောင်းတာကောင်းပါတယ်နော်မကောင်းဘူးလို့ပြောရှိတယ်ရှိပါဘူး Yeah what is good totally good enough
That's a good question, or a good answer rather. Because you know why? If you don't know how to do this, you can't do water counting. Because what have I just done? What did I just do? When we do water counting, what's our first step?
ဘာသာကောင်းပြီးလို့ပထမဆုံးစိတ်ပါလို့ပါ
You need to find the domain.
Oh, okay. We're connecting. Yeah. Domain. Okay. So what have I just done? When I make this watershed, I've defined my domain. But I haven't defined
ဒီပါ
my vertical yet. Okay. So do we want to include groundwater? I think we have our hydrogeologists. Should we include groundwater? Yeah, I think so. So this is my domain now, right? Now we need to talk about, we have the spatial domain, so what should be our temporal domain? When you guys are deciding your future right now, you decide 1975, then the next 3 days we're going to spend in 1975. But if you decide something more recent,
ဒီ
like 2018 for example, would be a good choice.
ဒီတော့ဘာလို့ဒုံမိန်းကိုသတ်မှတ်ပြီးတော့ကောင်းတင်းလုပ်မယ်ဆိုတော့မထည့်အောင်မယ်အခုလုံးအချိန်ရောနေရာကတော့ကျွန်တော်ပိုင်းပြီးတော့သူဒီပိုင်းအချိန်ကိုကျွန်တော်တို့ဘယ်လိုလုပ်လဲအဲ့ဒီလုပ်မဲ့ဥစ္စာကိုဒီနောက်3ရက်လောက်ဆက်လုပ်ပါလိမ့်ဟို1995ကိုပြန်သွားမလားအခုလည်း2018 2019လောက်ကိုပြန်သွားမလားဒါကတော့သွားလို့မရဘူးကဏ္ဍမရှိသေးဘူးဒါကိုယ့်အကိုစဉ်းစားကြပါမယ်
2018 is okay? Okay, so we're going to use that for future. Now, if the world were perfect, which it isn't, right? We would have measurements of something right here and right here. What would be really important to measure right there? Think about our fluxes. When we think about the fluxes on this map, what are the, so we have our domain, right? What are the fluxes now? Can we conceptualize this? Yeah, so what are the ways that water comes in or out of this domain? Outflow over here, or where's the outflow? Yeah, this is here. So this is the South Yama Tong outflow, and this one here. Okay, so that's a flux, right? So what other fluxes are there?
နောက်ပါရှိတယ်မင်းတို့စီးဝင်တာဒီကိုစီးထွက်တာ
Groundwater or what?
Groundwater တွေကိုကျွန်တော်
Sorry. What did it say for groundwater?
ဒီရောက်နေ
Rainfall.
ဒီပေါ်
Okay.
On the Todong ranges.
Say it one more time.
Rainfall on west of Todong ranges.
Yes. Okay. Good.
Singled into the
So
aquifer.
this rainfall here, right? Okay. So that's an important flux, right? What about the rain down here? Is that important also in terms of flux? It's maybe not as much, right? Maybe more rain happens here because of the mountains, but there's still some rain here, right? It's important. Yeah. Good. So the rainfall for the whole thing is a flux, right? What other? I think you were mentioning another flux.
နောက်ပါရှိတယ်ကစီးဝင်တဲ့ဟာစီးထွက်တဲ့ဟာ
Okay, good. Yes, right. So some of that precipitation, right, is evaporated back, right? And And there's one more possibility. I don't know. It depends on geology. I'll give you a hint. It depends on geology, but there's maybe another flux we should think about. I don't know how big it is though. So
โอเคเดี๋ยวsee that
here's the question. Okay, I have a question for the fillet. You know, in March, is the Chong flowing? Is there water in the river right now in March or April? Is it dry or flowing?
No,
Right.
not flowing.
Yeah.
No, not flowing. MS non mine flowing. That's south mine is not flowing.
Okay, so this one is flowing.
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 Okay, just a little bit, or how? Do you know how much?
Little.
Little bit. Maybe like 1 cubic meter.
And more than
Maybe 5.
don't try to.
Oh, we need to measure it, don't we? Okay, yes. We don't know, but if we had to guess, maybe 5 maybe? I don't know. Maybe we see a picture. It would be great if we could see a picture of this. Okay, that's
I will show you.
182 above. 182 above.
180.
180.
Wow, okay.
Vertical.
That's a lot of water.
Yeah.
Yeah, okay, so this one's bigger, right? So that makes sense that it's higher than this one. But this one is dry right now? Yeah? Okay. If I went to this spot right here, and I started to dig in the river's dry, right? But I started to dig in the river. Maybe I had a tractor and I started to dig. Would I hit the water at some point? Would I hit water maybe? Yeah? Yeah, maybe. So maybe there's groundwater, right, flowing that I can't see, right, in the stream channel, right? So maybe even though the stream is dry, there's actually flow in the subsurface, right? So what do we call that? We're going to call that. Yeah, base flow is kind of a tricky term because most stream people would think, oh, base flow is the minimum flow in the river actually itself. Now, I agree with you. It is kind of it makes sense to be like a base flow, but we're going to call it a groundwater outflow. Yeah, because it is in the ground. It's not up on the surface. Yeah. Okay.
ဒါပြီးရင်နောက်ထပ်သူကစလောက်ပြောင်းဖြစ်တယ်။ရောက်ရည်တော့စိတ်ဝင်သွားတာပေါ့နော်။ရောက်ရည်လည်းအဖြစ်ပေါ့နော်
Okay.
။ပုံမှန်
So we have maybe 4 things, right? We have 4 fluxes. Yeah, we have what? Precipitation and okay, and we have stream, yeah, and groundwater. Do we have any stream inflow? Are there any streams that flow into our domain? This is remember I tricked you all yesterday with the Ayeyawadi. I said if you look at the whole Ayeyawadi watershed, are there any streams that flow in? No. That's the definition of a watershed, is that there's no streams that flow across the boundary, right? So by definition, the way that I've drawn our domain means there's no streams coming in. And there's only one stream coming out for each watershed, right? And I'm lumping them together. Okay? So we have 4 things: precip, evaporation, stream flow out, groundwater flow out, right? Now maybe groundwater inflow is possible. It depends on geology. If there's a fault, maybe a displacement, maybe some weird geological structures. Maybe there's some groundwater flow across the boundary. Probably pretty small. Do you think it's small? The groundwater inflow? Maybe it's small. I think we maybe ignore it for now, okay? Because it's too hard to measure. Okay. So this is really, really important. I'm not going to go to the next slide until yeah, I'm going to go to this.
အခုကျတော့နောက်ရှိစက်ကပါဒီကိုဒီ domain တစ်ခုလုံးတော့အဝင်နဲ့ပတ်ပြီးတော့ရှင်းလို့ဟုတ်တယ်အဓိကအဓိကပြောနေတာတော့ဒီပြောနေတာစမ်းကြောင်းနဲ့ပဲဖြစ်စေချောင်းနဲ့ပဲဖြစ်စေဒီအဲကိုဝင်လာတဲ့ဥစ္စာမရှိဘူး watershed ရေဝေရေလည်း data လို့ပြောလိုက်သူကဒီရတာသူ့ရဲ့ကိုစီးဝင်တဲ့ဥစ္စာမရှိအောင်လုပ်လို့သူရဲ့ပေါ်လာလို့ဆွဲရတယ်နော်အဲ့ဒါအဓိကဆက်ကတော့ဒီမှာပြည့်တဲ့ရောက်ဓမ္မချောင်းအောင်ဓမ္မချောင်းအောင်ရှိတယ်သူဘယ်လိုဝင်လာလဲရှင်းနေတယ်အဝင်ရတော့ဘယ်ရနေတာလဲဘိုးကြီးရတယ်အဓိကကြာဘိုးကြီးရတယ်အဲ့ပြန်တော့သွားတဲ့ကြောင်တော့ခုကဖြစ်ပါလေဒီလိုတော့စိတ်ဝင်တာနော်ဒါလည်း
Good. So, in terms of the color of this land now, is there anything that's interesting about the color of the land? Just using our eyes, what do we see? What do we see up here? Yeah, right. It's green. It's forest, right? Do we see any green areas down here? Anywhere? Is it green here? This is dry. Maybe it's green here. Kind of. There's like a green spot though right here, right? Do we see that? See how green it is here? Yeah. Why is that green? Do you know why is it green? Because what? Yeah. And where does that water come from? Where does that water come from?
Water and salt.
Yeah, because there's these artesian wells, right? And there's some reservoirs up here, right? I don't know. Maybe there's a reservoir over here somewhere. We'll see it in the next slide. But this is green because there's a water source that we can irrigate with, right? Okay. So can I go to this map now? So what is this? This is land use, land cover data, right? And water accounting relies on good land use, land cover data, okay? Now this land use, land cover data was done completely with satellite information. And it is not perfect. I'm positive of that. There are definitely problems with this, but it's the best thing we have, right? So we're going to start with this. What we need to do is we need to ground truth this data. We'll talk about that in a second. But what we can see right away is, okay, the green, what's the green here? Forest. So this makes sense. I've been checking this on the Google Earth, right? So yeah, so forest area, this makes sense. I don't know, yeah, this is good. You can kind of go back and forth and see. Yeah, maybe that's good. This is good, right? You can really see that, yeah? So it looks pretty good for the forest, right? And what's this one here? I think it's this one here. So it's water managed single. So that means I think we get one irrigation or one crop out of the water. Okay, that makes sense because it's all right here in this 99 pond zone. Okay, and then what are these blue things here? And this is a water body. Yeah. So I mean, this looks pretty good. The land use land cover looks pretty good, right? The EMI, remember Dr. Kuzma said the International Water Management Institute, EMI, they made this for the whole. I think for all of Myanmar. I can give this to you if you want this. Yeah. If you use it, you just have to reference where it came from. Okay. But I'll put this on the drive. It's like 700 megabytes. This kind of thing. So this is really cool. And with this information now, we can actually start to do the water counts, right? But we need to start measuring stuff. So can I go from this picture to this picture? Or this is just our conceptual, right? So this box here, what does it represent? Our domain, right? And I haven't specified the time here, but if I did, I'd say 2018 would be our time, right? And so we have fluxes, the arrows, and then we have changes in storage. We haven't talked about that, have we? So we talked about the fluxes here, but we didn't talk about changes in storage. How can storage change in our domain here?
Maybe you are a year or down a ship. We know the vida, a little vida. Bloating a gown, slowly. Yeah. What are the take that?
she think one of the things that rainfall solution will be the causes. And
Okay.
this gentleman said that change in water level.
Okay, so it's interesting, the fact that you said causes makes that answer right. But we're not thinking about the causes of the changes, actually physically what happens when we have a change, right? So it's correct, it is correct, the evaporation and rainfall cause it. But what's changing? And it's changing the water level, right? The actual groundwater level maybe is going down, right? Because we're pumping. So there's groundwater is one change in storage, right? And what's another one? Remember, we had 4 ways that water could change in storage yesterday. We're going to try to link those. Does anybody remember the 4 from yesterday? Okay. Soil moisture, what? Groundwater, reservoirs, and... Okay. So good. So see, we've memorized them, right? And that's the first step. It's good. We have to memorize because we're learning new language, right? But now we have to know what it means. So with those 4 things, which of those 4 things do we have in our domain? Right? What do we have? We have groundwater intake, we have soil moisture, and we have reservoirs. Do we have any glaciers or snow? No, it's not high enough. I think we have the, well, I don't have the I don't have my topo map shown, but we can see here, this is the 4,000 or 5,000 meter area. In our Boleto Basin, like 1,000 meters maybe is the highest. Maybe these mountains here, maybe like 1,100. You guys think in feet? Maybe they're like 3,000, 4,000 feet, maybe.
พวกเราลงน้ำเราทุกอย่างนี่
Yeah. Okay. 6,000 maybe.
Yeah, 6,000 feet.
Okay.
At the highest feet.
Okay, so maybe like 1,600 meters. So it's well below where it snows. So there's no snow. Okay. So now we know something about this, right? The change in storage. So which of these numbers can we get rid of? We can say, okay, 0. We talked about this. There's 2 arrows, there's 2 fluxes we can say we ignore because of how we drew our domain.
အခုအနာကဒိုမေကိုကျွန်တော်ပေါ်လာထက်လိုက်ထက်လိုက်လို့ဒီ6ခုထဲမှာ2ခုပယ်လို့ရပြီလေဟိုရအောင်နားလို့ရ
Yeah. Yeah. Can we say these are 0? I mean, this one for sure, right? Because by the way we drew our domain, it has to be 0. So we cut this one. And then this one, yeah, it's probably 0. If there's weird geology, maybe not, but we're going to ignore that. So we go like, okay, well, I'm not going in order, but we can cut that. Inflows, we've already talked about this. Precipitation. These are possible inflows, right? Possible inflows. And then these are possible outflows. Evaporation, surface water out, groundwater out, right? Now we can start cutting stuff here. So we cut those 2, and we're left with this picture, right? And it's funny, it's just, this is so simple, right? It's like we have this box and 4 arrows, right? And then it just gets more complicated from here. But the point I want to make here is we need to measure or estimate these things, right? And we get like one freebie, I'll call it. One freebie, you know, freebie, like one thing for free. And the reason for that is I need a pen maybe to show this. Remember our equation? Don't do that. Okay. This one. Okay. Okay. So I can write on this one? Okay, we have our equation. Remember what's our conservation mass? You guys tell me again. N equals. Okay. So our inflow outflows are what? That's it, right? That's it. We're inflow, okay? So then our outflows are what? Okay, so ET plus groundwater plus right? And what's inside of this one? What's inside of this? There's three things.
storage ကြောင်းလေးတော့
Reservoirs. Okay, good. Okay. Now, in algebra, when maybe you were like, when do you learn algebra? When you're 12 years old,
Yeah.
something like that, 12 or 13, you start learning about algebra. That's where you start putting letters in math. It's like, where does the letter come from in math? Anyway, math is about numbers. Why are there letters? Okay. In algebra, you learn when you have one equation. How many equations do we have? We only have one equation, right? When you have one equation, how many unknowns can you have? You have one equation, you can have one unknown. Okay? Can I make it real simple? Watch this. Okay. X equals y. How many equations is that? Okay. If I tell you that x is 10, tell me what y is. Yeah. I don't need to tell you why. You can figure that out. I just tell you x, you tell me y. Right? I can make it kind of more complicated. Okay. Y is equal to 0. What's x? I don't know why I put x on this side. This is backwards. This should be a y. Go ahead with the y. Okay. So you get the point. If we have one equation, I tell you one variable, you tell me the missing one, right? So what does that have to do with this? You connect these for me here. What does this have to do with this? Because at the end of the day, I want to solve this equation. I want to put numbers in for every single one of these letters here. Do I need to measure every single one?
ဒီတော့အဲ့ဒီအရင်ရှင်းပြတယ်လို့ equation နဲ့ကြည့်ပြီးတော့ equation မှာဟိုမတိဂိမ်းကိုဒီအဲ့ဒီတစ်ခုပဲထားနေတယ်။ကျန်တဲ့ဥစ္စာတွေတိသွားပြီဆိုရင်အားလုံးအသာဖူးသွားတာလေ။မတိဂိမ်းကြီးဖြေထွက်တာ။အဲ့တော့အခုဒီတော့ကသူပြီးတော့ပြောတာကျွန်တော်ပြောထားလိုက်လို့တော့တချို့ဟာတွေတိုင်းလို့ခက်တိကျတိုင်းကိုခက်တယ်လို့ထားတယ်။မတိုင်းမဲနဲ့ပါလို့ရမယ်။တိုင်းလို့ရတဲ့ဟာကိုစားထိုးသွားတာနဲ့စားထိုးပြီးပြတ်သွားလိုက်ရင်ဒီမဆုံး။ရတယ်နော်အဲ့ဒါတော့ဟုတ်။โอเคအဲ့ဒါအခုဒီအဖေကသူလေးတာကိုရှင်းလိုက်ပါဦး။အားလုံးတိုင်းလို့လား။ No. That is you don't need to measure each and every one.
Yeah. How many can I not measure? How many? Only one, right? Because how many equations do I have? I have one equation, I can only have one unknown, right? One equation, one unknown. If I had another equation, right, then I could have two unknowns, but we don't have another one. This is our only equation to work with is the conservation of mass, right? So then what we do is we say which of these is the hardest to know, right? And the one that's hardest to know, we're gonna use the math to get. We're not gonna measure. It's called a closure term. Okay.
အဲ့တော့ဒါပြင်အခုဒီမှာလည်းကတိုင်းမှုဥစ္စာကအားလုံးတိုင်းမှုမရတယ်။ဒါပေမဲ့ခက်တာချင်းတူတူမှာအခက်ဆုံးဟာကိုပြောပါလို့လည်းမသိငယ်ဖြစ်ထားလိုက်။ကျန်တဲ့ဥစ္စာတွေကိုရအောင်တိုင်းမယ်ဒါမှမဟုတ်မှန်းပေါ့။တိုင်းနေတယ်ပြအဲ့ဒါကြရင်တော့ပြောတာတော့ကြိုက်တယ်။တိုင်းမှုအခက်ဆုံးပြရပြီ။ဟုတ်။မှန်းရ။
Okay. I got free data for all of Myanmar for precipitation for the last 10 years. It's a thing called CHIRPS, CHIRPS, CHIRPS. It's a wonderful product. Every 5 kilometers, I know the rainfall. Every 5 kilometer by 5 kilometer pixel, CHIRPS. I have that data for free. I downloaded it in 2 hours. Okay, so I have this. Okay, ET data. I also have ET data. Every kilometer by kilometer pixel. Then the surface energy balance method. It's called the simplified surface energy balance operation, CBOT. S-S-E-B-O-T, CBOT. So we're going to go through this stuff. I'm just giving you a preview. So I have ET. Now these aren't perfect. It's better to measure this on the ground. We need rain gauges. Right? We'll talk about rain gauges. We need to correct maybe this remote sensing. But we have something to start with. Do we have any information about this? Are there any measurements of flow? You know the Yama, the north and south Yama? Do we have any measurements of flow from the river? Do we maybe have some or no?
ရှိလား
We have that's yeah.
We do have some.
We do.
I'm going to be so happy if we have some.
She does.
I'll be like, yeah?
ဆိုင်ပြီးပြီလား
We did.
ရတယ်ဒီ
Yeah?
That's yeah. That's we also did. Service run up assigned. Yeah.
Because next time I come to Myanmar, I hope we can go and take some measurements together. Because I love to see this. I'm a measurement guy, so I love to measure
I
stuff.
think you see that they already measure
No,
yeah, the North Yama Creek or
Yeah,
they
Chao,
already
yeah.
Chao, they already did the northern part
Yeah.
more or less it's flowing all year
All year,
round.
yeah.
But the town where over there
Don't know.
yeah
Não vai, não é mal, mas não sai.
ဟုတ်ကဲ့တိုင်းလာပြီဟောတိုင်းလာကြ flow တိုင်းလာ
Flow that.
flow rate flow rate လာပေါ့
Flow rate process နဲ့သူကဒီကရှိတော့တယ်ပြန်ဆိုင်ပါတယ်
ကျွန်တော်တို့ပြန်ဆောင်ပြီး
Okay, okay. Yeah, so they have more or less reliable figures for the flow rate and volume of the northern, yeah, all the northern one.
Wow, okay, great, good. So every day we have a number, or every month, or how frequent?
Once.
One time. Okay, okay. I'm not so happy. But it's better. 1 is better than 0.
Yeah.
10 is better than 1. So 1 is better than 0. Because we can use that one number to see is the data making sense. 1 is so much better than 0. So I'm still happy. Okay? So we have some data about this, right? So yeah, I'm going to check it. It's like maybe, yeah. But what about this one here? Do we have any data about?
Changing story.
This is a kind of a difficult one, right?
So is it very difficult? Kinda,
Well, we have to think through the 3 things again, right? What are the 3 things?
yeah, maybe the change story ကြပါတယ်
Okay, so let's just start with reservoir. What do we need to do to know the change in reservoir?
Swine motion.
Yeah, we'll talk about soil moisture, but for now, the reservoir.
You know many about
And we need to know the water level, but we also need to know something about the geometry of the reservoir, right? Yeah? So we need to have like a stage volume curve, right? And we need to have stage data for the reservoir. If the reservoir is big enough, we can get that level data from satellites, right? But I don't know if these are big enough. Do we have any data of the reservoir level? Does the IWUMD measure the water level in those reservoirs we saw? The lakes?
တိုင်းရပြီဒီနောက်ကနေ
ဒီလိုမျိုးဒီမှာကျွန်တော်တိုက်တာတော့တုံးနေစားတော့
ဟိုကနေနဲ့ water level ကိုတိုင်းတာ
ဘာလို့လဲတော့
ညာ
confusion ဖြစ်နေတာပဲ
อ๋อဆယ်ကိုပဲဆယ်ဟုတ်တော့ဘလို့ fluctuation ပေါ့ဒီအညက်ကိုပဲတိုင်းတာဟိုတိုင်းနဲ့
ဟောတိုင်းတဲ့ဆိုတော့ဟိုကဆမ်မတက်ပြီး
ဟုတ်ကဲ့တိုင်းဟုတ်ကဲ့ဟုတ်ကဲ့အဲ့ဒါ
အဲ့ဒါကို
ဟုတ်ကဲ့အဲ့ဆယ်နဲ့ရေးတော့မယ်ရေးတော့မလုပ်ဘူး
ဟိုကကျွန်တော်တို့ကကျွန်တော်ကပုံပြတယ်မှာ
ညာ
ဟုတ်ကဲ့ဟုတ်ကဲ့
ဟုတ်ကဲ့ဟုတ်ကဲ့တော့
ဆယ်ဦးတော့မကြည့်ကျွန်တော်တိုင်းမဲမောင်းပါ
အော်ဟုတ်ကဲ့ဟုတ်ကဲ့
ဟုတ်ကဲ့ဟုတ်ကဲ့
all these 99 balls like 3 years later of water level.
Awesome. Okay. So that gets into remember the 3 things here. We have groundwater, change in groundwater, right? We have change in soil moisture, and then change in reservoir level. Well, let's just do it. So this one term, right, is these 3 things, right? So that's really great. So we have some data about how the groundwater levels are changing. We know something about the geology or the porosity, right? Of the specific yield of that geology, then maybe we can get this one. Reservoirs, we need to know the level and the geometry, right? So maybe we can estimate this, maybe. Soil moisture, do we have any data about soil moisture?
ရေမှာအဆိုးတိုင်းတာအဲ့ဒါကိုတိုင်းလို့တစ်ခါမှတိုင်းလို့မရဘူးနော်တော့အဲ့ဒီပြန်လို့ရှိတာ
So we can get soil moisture data actually from satellites also. So we can use, we can also get it from modeling, right? We can do a root zone balance, a root zone modeling, right? There's all sorts of different root zone balance models, but I don't know. So there's like, we know some of this one and we don't know some of this. We know some of this one, and we don't know some of this. So which one do we want to solve for? Which is hardest, do you guys think? We have to choose. Storage. You think we should solve for this one? Okay. So what that means is we have one measurement of this one, and we're going to use that one to solve for this one. Okay. Now this gets into uncertainty. We'll maybe go through this kind of quick, but which of these numbers do you think is bigger? All right, so in 1 year, do you think the flow in the Yama is bigger or the change in storage within the storage is bigger?
သူ့မှာပြောင်းလဲရများမလားဒီအိမ်ချောင်းထဲမှာစီးတာများမလား
Now it's the change in storage. It's not the total storage, it's how it changes in 1 year. Do you think the flow in the river is bigger or the change in storage is bigger? I think the flow is definitely bigger, right? Because maybe the storage is changing, but it's just in the reservoir, and it's just the root zone, and it's just in the groundwater, right? But the flow, right, is it could be substantial. I mean, I think this could also be big, maybe. But if you look at 1 year, when we do 1 year, we look at like before the monsoon to again before the monsoon the next year. The total change is probably not that big, right? Because it goes up, it goes down, and it comes back to kind of the same spot, right? So maybe the monsoon, the storage goes up, the winter and summer it goes down, and then it comes, well, yeah. Well, it doesn't come back up until it starts raining again, so I didn't do that quite right. Like something like this, yeah. Yeah. So I think maybe we should solve for this one. And maybe assume that this one is maybe small, or maybe we use some of our data to make an estimate of it, right? And then the nice thing is we have this one measurement, right? If we solve for this one, we can check with the one measurement we have and see is it close, right? So you see how we can solve for this? We take this one, and then we put these ones on this side, right? So we'd say P minus ET minus delta S has to equal groundwater plus surface water. Okay. So I think maybe we've agreed on the basic structure of our water balance, right?
ကျေတော့နော်ဒီဘင်းကိုဖွင့်ထည့်လိုက်တာလေးတိုင်းလို့ရနိုင်ပြီသိနိုင်ပြီနည်းလေးကိုထည့်လိုက်ရင်ရှင်းအဲ့ခက်တဲ့ကဏ္ဍကိုဘယ်လိုလုပ်အတိကိအနေနဲ့ရှင်းပြရ
Yeah. Okay. So this is an option. The other option would be to solve for delta S. You see how that would work too, right? Okay. So I'm going to put that up here. So one option is we can measure or estimate these fluxes, and we can solve for the change in storage, right? So that would be as if we got this one all by itself. So we did P minus ET minus groundwater out minus surface water. All of that would give us delta S, right? So that's this option. We call that the closure term would be change in storage, delta S. Or what we just decided on maybe is a better idea is we could measure or estimate these two, and then we could solve for this one. See? So that's the mat of the water columns. I haven't even started talking about what I was supposed to be talking about.
Yeah.
Okay, I got 12 minutes. So now we go quick. This is important though. This is real important. Am I going too slow or is it about right? Is it about right?
Yeah, need it. Yeah,
Okay, okay. Can I go? I'm gonna go fast now. I can talk pretty fast, so we need to go through this before lunch, so I'm gonna go fast. Okay. So now we pick up the pace. Okay. So we have P, we have ET, we have surface water, groundwater, and changes in storage. How do we actually measure these? Right? That's the question. How do we measure them? So I'm gonna have one slide about each of those fluxes and changes in storage. So precipitation. Okay. The best thing we can have is a network of rain gauges, even manual rain gauges, just a bucket catching the rain. Measure it once a day. That would be so valuable to have because I have this P data, but it's from satellites. I want some gauges that I can check my satellite data with, right? Okay. So gauges are important, but when we measure with a rain gauge, how do we know that the rain right here is the same as the rain over here, right? Like if you have the whole Malay subbasin, can we rely on one rain gauge? Is it okay?
Yeah, we need to be at a time is we give our you are a more, if I were a body, you have to do the body. The design is cool on the body. We had a degree at a cool at it.
Yeah.
No. If this is the Palais, right, and then this is the Chinwin here, is the rain in the mountains the same as the rain in the central dry zone? No. So if I put one gauge there, it wouldn't be representative, right? So how many gauges do I need? 10? 100? 1,000?
We can say 100 to 80 rainfall.
Yeah, we can, but what does that assume? If you take one point of rain and you change it to an area, you're assuming the rain is the same. And we just decided that the rain's not the same, right? But say it again, though? Yeah.
If we have only one rainy
Yes,
station,
yes.
we can change one rainy station is one rainfall.
Yes.
So we can change from one rainfall to area rainfall.
Yes.
That area rainfall is better than whole land subdivision.
Yes, yes.
If we have only one rainy station.
Yes. But how do we know that the one point we measured, say right here, how do we know that that point represents this part of the watershed and this part? Because isn't it different? Isn't it different? We just said it's different.
So
So
if we don't have many rainy stations.
we might have to assume. Yeah, okay. Okay, so but we should only do that if we have to.
That was about the other day, the time for it, the kind of people the other time, rather than go to the area cool on the country. The very who do not know you down the lady, down any cheating, never talk to the idea. She didn't have a name on the other cheating. No, they'll find it out by number to be not to. Hello, get in the other time. The other time you go, it is not a cool, a lot of my dear Baba, let you go. Hello, you saw that. Yeah, where Babu, I don't know. Dig up doing it, Johnny. More eating, more tight, I will be Yam, that will be Yamia Tiny, only, of your Lebanada, and was the only go you won't have you over, of being a net, yeah, even the Jama Jam. Hello, send me Korea, yeah, Papa, they do, who want to put behind the child. Oh, yeah, they are, and it's the teach up, teach much. That will train the child, the guy who send it teacher very far. And let them out, the one of your title, big I thought of it. She took it as she put on. Other.
ကျွန်တော်တို့ဒီရတဲ့ပေါ့တောင်းတဲ့ခါကျတော့ကိုညောင်းရတယ်အဆောက်ကိုညောင်းတာဆက်ပြီးတော့ဆရာဦးတင်ကသူကမြန်မာပြည်လုံးအတွက်ဟိုပါတော့ rain desert is in the red မှာပေါ့ဒီလိုမျိုးအဲ့ဒီဥစ္စာကိုပါလို့ပြတဲ့အဲ့ဒါအတိုင်းကို90 point လေးပေါ့ဒီကကြောင်းမှာပေါ့အဲ့ဒါကိုကြောင်းလို့အဲ့ဆရာဦးတင်ကသူကထားလို့ဆိုတော့
အဲ့ဒါရှိတယ်အဲ့ဒါဥစ္စာ
စာနည်းနည်းပြန်ပြပြီးတော့ဒါကကျွန်တော်တို့အရင်လုပ်တဲ့ဟိုဒီလမ်းပါနော်
ဘယ်လိုလဲဆေးချင်မှာနဲ့ဒီမှာတော့သူတွေတရားတွေလောက်တာလည်းများအင်းရင်းဖို့အဲ့လိုမျိုးကြောင်း
ဟုတ်ကဲ့အဲ့လိုပြန်ပြောပြပါဟုတ်ဆိုlike what we used to do for actual practice like since we don't have administration
Right. You gotta break it out by sub-basin or something, by region. Yeah, exactly. Exactly. So, good. Okay. So, in addition to these types of gauges that we were talking about, we can do modeling, right? But I'm not a, yeah. In order to make a good model, you actually need good data. So, you can't really do this without this. And then also the remote sensing approach. There's these different ones. This is TRIM, or the Tropical Rainfall Measurement Mission. Global Precipitation Mission, CHIRPS. I don't know what CHIRPS stands for, but it's from the University of Santa Barbara. This is a great product. Every kilometer we have rainfall. So this is what we're going to use. So just to give you a picture, this is the roof of my old house in Nepal. And of course, because I love to measure things, I have 4 rain gauges on my roof, right? So I have a tipping bucket rain gauge. You have tipping bucket gauges here in Myanmar, maybe? It measures the intensity of rainfall. We'll talk about that tomorrow. I have this gauge called a COCOROS, Community Coordinated Rainfall and Hail Society or something like that. They started in the U.S. This is the government gauge. So they have the DMHM. You guys have the DMH. This is the Department of Hydrology and Meteorology. You have the Department of Meteorology and Hydrology. So just switch. Do you use gauges like this? Does this look familiar or no?
ဆရာတို့ဒီမှာတိုင်းတော့ပါတော့ရ
Who's from DMH again? Do you guys, I think, or, yeah. Do you know for measuring rainfall, do you use a gauge like this? Does this look familiar? Or? Yeah, this is a manual gauge. There's a hole in the top, and then it fills up the cylinder, and then you measure the volume. Something like that. Yeah, I think it's the same, similar, maybe, similar. And what is this? This doesn't look like a rain gauge. This is a soda bottle. Yeah, we've used 500 of these in the Kathmandu Valley. 500 gauges in an area that's a quarter of the size of the Palais Subbasin. And we measure the rain with students, right? So every student, I told you, every student studying water in the world should measure the rain. And then we can stop complaining about not having data, right? And we should do it with our smartphones so that we share the data, okay? Can I tell you more about that after lunch? I'll give you like a preview right now. I'll tell you more after lunch, okay? So these are different options for measuring rain, okay? And then we have evaporation, right? So that's precipitation. We have evaporation. There's a thing called FAO 56. Okay, it's called it's a way of estimating evaporation from cropped areas. Okay, crop coefficient times reference ET. I'm going to spend lots of time tomorrow talking about that, so we'll just skip that. These are some other techniques that are more complicated. Eddy covariance lysimeters, DTSS for distributed temperature sensing, using fiber optics, and also remote sensing. This thing here, called the surface energy balance method. Surface energy balance. We have the mass balance, now we have the energy balance. We'll talk about that tomorrow, okay? These are just like a preview. And here's this idea of evaporation, transpiration, okay? These are 3 different land covers in the Kathmandu Valley. Can anybody guess which one has the highest rates of evaporation? These 3?
ဝိကရဏညာ
This one?
No.
You think this one has the highest rate of evaporation? The most evaporation? This one? This one? This one? Or this one? This one.
ဟောလာလေလာအောက်ဆုံးလာ
We better talk about this for a second.
ရဝိကရဏလေ
Evaporation and evaporation.
Okay, sorry. Total. So both evaporation and transpiration. So which of these has the most of total? Okay, I'm sorry. It was a bad question on my part. Okay. Yeah. So total flux of evaporation and transpiration would be this one and this one. This one? you guys ever heard of a thing called leaf area index? Leaf area index? You know leaf area index? Which of these two land uses or land covers has more leaf area? Do trees have more leaves or do perennial crops? Trees have more leaves, right? And the more leaf area you have, the more transpiration you get. Okay, so which one has the most? Probably this one, right? And then followed by this one. This would be like a managed land use, right? We have rice, we have some corn. This is in Nepal also. This is the Shiva Free National Park. This is out behind our house there. This is from the roof of a place in Pottenberg Square, okay? This one has so much evaporation and transpiration, or not so much? It maybe has some evaporation from maybe, yeah, not much though, right? Okay, stream flow. Like I said, I've spent a lot of my time doing this all over the place. I think you guys maybe went out and took a measurement of the flow one time. That's good. Very good. We can also measure the water level and build what's called a staged discharge curve. We can measure the velocity of the water. We can do numerical modeling with like a rainfall runoff. I think one of our colleagues was talking about inundation models. That's what this would be. It's a way to estimate stream flow. And we can also use remote sensing. This is an emerging approach. It's not so good yet, but it's getting better. Can I show you a quick picture? This is my friend Sven in the Kathmandu Valley measuring the Manahar River. Okay? So if you want to measure flow, guess what? You have to get wet. You need to get in the river as long as it's small enough to get into. And you get in there and you measure velocity with this thing. This is an acoustic Doppler velocimeter. They made an acronym for that, ADV. It's easy. And this measures velocity. How much does this cost? $10,000. Whoa. So that's why we don't have any stream flow data, right? And it's not so easy to use either, right? So I've trained a lot of people how to use this. I love this. This is my favorite thing in the world, to get in a river and measure the flow. It's like my favorite thing in the world. So maybe we do one of these measurements. In the Yama River, is it too deep? No. Or can I do this? Maybe this high? Yeah, no problem. Don't tell FAO though. Okay. Yeah, no problem. Okay. Is it moving fast or kind of slow? Oh. Okay. Anyway, so this is not easy, but it's fun, right? Okay. Nobody's done this. I think I asked this. Has anybody done this? Oh. We have to all go as a class. And is there a river nearby? Maybe next time maybe I can bring this next time and take the measurements.
Yeah, there is a few streets.
Okay. Well, we'll move on. And then changes in storage. So this is the last thing that we'll have lunch. Because I think, yep. So these are hard to measure, right? But we can measure the levels in the reservoir, like we talked about. We can measure the levels in the groundwater. We can measure soil moisture with sensors. We can also do that with remote sensing. But what's really important is, what I really like to hear is that there's some groundwater level data. That's great. That's good. If we could start measuring the reservoir level, that'd be really wonderful. If we can do that with a picture, all we have to do is take our smartphone and take a picture of the lake once a day. Then we have that data, okay? And then we want to measure the pumping from the wells. That'd be good. Maybe you have some discharge data from the artesian wells.
ဒီရင်းတွေဒီဗီဒီရှာရင်းတွေရှိတယ်။အတက်ပြောရတယ်ကျန်သေးတာ
Exactly.
Yeah, this well.
Good. Good. Okay. This is how complicated groundwater is, right? You guys, the hydrogeologists in here will. We don't have time to go into this, but the changes in storage actually are represented by fluctuations in what we call the water table here, right? So if the water table goes down, right, then the change in storage is negative. If it goes up, it's positive, right? There can be unconfined aquifers. There can be confined aquifers. It's called an aquitard here. This is like a basement material. Everybody seen a picture like this? Has everybody taken some groundwater course maybe? Okay, we spend more time on this tomorrow. Okay, I'm a hydrogeologist also, so I know this stuff. Okay, we do this. And this, where's this? This is the last picture, I think. This is at the top of the world.
ဒီဘက်ဝင်လာတော့ဒီပေါ်နေတယ်ဒီပေါ်နေတယ်ဒီပေါ်ဒီပေါ်လာဟုတ်တယ်ဒီပါတာ
Yes, the Everest is hiding behind that cloud here. This is Nuptse, and then Lhotse is behind here, and Everest is back here. Yeah. K2 actually is in Pakistan and the Karakoram, so it's way off to the west here. But you guys share the same mountains, right? The very east of the Himalaya is where the Aowani comes from. The same mountain range, right? This is called the Khumbu Glacier, right? The Khumbu Glacier comes from Mount Everest, and it flows down into the Khumbu Valley, right? Now, if that glacier was melting and it was getting less, is that a change in storage? Yeah? Yeah, it's a change in storage, right? If the ice is melting, then it's a change in storage. If the ice is growing, it's also a change in storage, right? So measuring this is difficult, right? You can maybe use drones. We use drones to measure the changes in volume. Yeah. This is one of my favorite places in the whole world. What is this? What is this? You can't see it very well. It's a yak. You guys know yak? Do you have yaks?
No, we don't have that, but maybe in the zoo, I don't know.
Yeah, they like it above 4,000 meters, so it's probably, yeah, okay. Okay. Stop, what is it? Sabi B? No. Tame Same, but what's the finish? The BB. BB. Okay, so 1:30. Okay? Sorry, I keep on cutting your breaks short. part of that water that's flowing out. Probably not. But we could build more reservoirs. Some of this. By storing it in an area, we can move the water. Yeah. How do we link this picture to this? Because this is the water balance, this is water. How do we link it? I don't want to go back to that. Yeah, exactly.
Complicated. You can never be understand.